Okay, so for this week, I want to move a little bit away from talking about children and how children acquire language, and instead I would like to focus a bit on the parser and the grammar. So the reading for this week is a paper by Colin Phillips and Matt Wagers from 2007. And this paper specifically deals with questions about filler gap dependencies. Filler gap dependencies are what psycholinguists refer to, what syntacticians refer to as A-bar movement or double H movement, right? So that's the relationship between a word like the word what and the word eat in something like what did Sniffle eat. We'll build up to that because I want to start, like I've done in the past, with the beginning, right? I want to start by talking a bit about some of the bigger concerns that have motivated the way that we do psycholinguistics. And so that's what we're talking about today. We're kind of talking about the relationship between grammar and parser, or the relationship between the kinds of things we study in theoretical linguistics and the kinds of things we study in psycholinguistics. So it's worth mentioning that this is kind of a bizarre distinction that we as linguists make, right? So linguists and psycholinguists are both people who study language as a thing that the mind does. So why do we have this difference? Like, why do we have a class in our curriculum that's called psycholinguistics, and then we have a class called syntax, phonology, and so on? I have to say that as someone who is a professional psycholinguist, this is kind of a bit of a consternation for me, in that when I teach a class on psycholinguistics, I have to kind of cover a wide range of phenomena, right? I have to talk about things like phoneme perception, lexical access, morphological processing, sentence processing, and so on, whereas a person who teaches a class in syntax just gets to talk about sentences for the entirety of the class, right? So we have this term psycholinguistics and another term neurolinguistics, since I also work in that field, in which we're kind of defined not necessarily by the thing that we study, but rather by the way that we study it. So really what distinguishes psycholinguistics from linguistics, from the rest of the field of linguistics, is the methods that we use, right? So psycholinguistics is really defined by the fact that we use tools from cognitive psychology to explore language. So we use things like, we measure things like reading times, we look at things like brain activity if we're using neurolinguistics methods, or techniques like electroencephalography, and so on. So you can learn more about that by taking our psycholinguistics sequence. Obviously, many of you have already taken the classes in psycholinguistics, but some of you haven't, right? So, but what I want to stress here is that at the end of the day, psycholinguists and theoretical linguists are both interested in giving some explanation for why sounds, words, sentences, and meanings have the properties that they have, right? So that's kind of an unusual way of dividing up the discipline, right? And in the paper that we're reading by Phillips and Wagers, they mention, right, that this is in some respects to the detriment of the psycholinguists. Sometimes people might mistakenly believe that psycholinguists are somehow more interested or more entitled to say things about the mind, or more entitled to say things about the brain than our friends who do theoretical linguistics. But that's not necessarily true, right? I mean, as we've been talking about for the last few weeks, the whole broad program of linguistics is a part of cognitive science. We are studying aspects of the mind. And because our friends who do theoretical linguistics are able to collect data very quickly, because they use techniques that are simpler, that are lower tech, that are cheaper, that means that they're able to collect data from speakers of languages that are harder to access or that might be endangered. They are able to collect lots of data very quickly, and they're able to spend more time thinking about what the data means. I have to tell you that as a professional psycholinguist, one of the things that is sometimes frustrating about my field is it takes a long time to get the data that we want. And we have to find the money to pay for it, we have to train our students to use our equipment, and so on. And that means we get a lot less time to sit and think about what the theory is or what we're trying to achieve, right? So sometimes I think that there's a bit of a thought that maybe psycholinguistics or neurolinguistics are somehow a more true window into the mind, but I don't necessarily know if that's the case, right? So again, why do we have these differences in the fields then? Like, what is the point, right? Well, let's spend a little bit of time talking about where this comes from, right? Where the derivation of psycholinguistics comes from. Like we talked about in the first week, a lot of ideas, a lot of concepts in linguistics are actually quite old and have developed, been redeveloped, been rehashed over and over again, sometimes over centuries and sometimes over millennia. A lot of what we do today in modern psycholinguistics comes, as I said again in week 1, from work by Lynn Fraser and Janet Fodor in the late 70s and early 80s, in conversation with work that was happening by Chomsky and by other psychologists who were invested in the development of the generative linguistics paradigm, including people like George Miller, philosophers like Jerry Fodor, and so on. And one of the ideas that developed was this idea that there's some psychological reality or psychological validity to the different steps that we take in a transformational theory of grammar. So many theories of grammar, including syntax, phonology, and morphology, involve different stages or different iterations of some representation, right? So in a syntax class, you might say something like the sentence, "Who did Jane say was seen by Mary at the party?" That WH word who starts off as the object of seen. Maybe it moves into a subject position of that embedded intermediate clause. We see this because it controls agreement on the auxiliary was, and at the very end of the sentence, it gets pronounced at that very left edge. In phonology, you might have learned about things like rule ordering, so words like writer and rider for some dialects are distinguished from each other, and that's because even though the T and the D in the words writer and rider are both pronounced as a flap, in one case, a rule that maybe lengthens a vowel before a underlying voice stop might apply before we have done the flapping, right? So that involves a different application of different rules at different stages. And as we've talked about a little bit in class, one way to think about morphology is that you can think about words like slept and jumped as involving the application of some morpheme, a past tense morpheme, and then that gets spelled out in some way, right? So you can also think about even morphology. This idea that the different steps of these derivations in our theory have some psychological reality will come to be important in a few slides here, but I want to say that as Chomsky was developing his version of transformational generative syntax, he was quite careful to draw a distinction between what he termed competence and performance. So we've already talked about this in passing once before. I think most of the people who are coming from a linguistics background have heard of these terms before as well. But linguists have made this distinction between competence, which is one's knowledge of language, the kind of static knowledge of what is and isn't possible in your language, with performance. And performance is your ability to use language with the finite means available to you. So finite means on memory, on time, on attention, and so on, right? So we know that people produce sentences and can comprehend sentences that are maybe not quite perfect, right? That maybe are not grammatically well formed or that have errors. And we also know that people know the difference, right? So we know that there is some sense in which people can tell that they made a mistake or that they that someone said something incorrectly, but nonetheless we can understand them, right? So there is this distinction. What that distinction means is still somewhat controversial, right? So one might imagine that that means that inside of our heads there is one system that's called competence, right, that has its own rules and representations and so on, and there's a different system called performance. That's usually, I think, an assumption that people make, but it is an assumption, right? It is not something that is obviously true or that comes for free. Now, we can also say, for instance, that maybe competence is the what the system can do in principle, or what the system could do if it were completely unconstrained, whereas performance is how that system behaves under realistic conditions. That's a slightly different theory, right? So in the Phillips and Wagers paper, they discuss how these things might sound similar, but they're actually different, right? So those are actually different characterizations of competence and performance. And I think this is part of the reason why we have a syntax class where you go and learn how to draw syntax trees, understanding that that is some characterization of the competence of a native speaker of a language. But then you can also take a class in psycholinguistics where you talk about how those sentences get processed by a human, and that is understood to be a different kind of scientific endeavor, right? I think it's partially because we make this distinction. Whether that's always the right way to do things is a different question. So why do we make this distinction, right? So I already mentioned an example, right? We know that people can understand sentences with errors, and we know that people produce sentences with errors without necessarily thinking that that person doesn't know the grammar of their language. In class, I made the analogy, or I made the I suggested that this distinction is really useful when we understand things like second language learning, right? I have studied several different languages in my life, and when I use those languages, I often feel like I know the words that someone is saying, I know the rules of the language, but the speed at which someone is speaking is just a little too fast for me to keep up, right? So that's a distinction between my competence in that language. I know how to mark the verbs in my language or what have you, and my performance, my ability to use that knowledge in real time. So there's kind of one example that we often use to demonstrate this distinction between competence and performance, and that's the example of center embedding, right? So for instance, I can give you a sentence like "the mouse ate cheese," and I can show you that we can take another sentence and I can stick that in the middle. I can attach that to the noun phrase as a relative clause, and I can produce something like "the mouse the cat chased ate cheese." Now, this is a kind of reduced relative clause, right? So this is an analogous to saying something like "the mouse that the cat chase ate cheese," but without the that. And so we understand that the mouse is the object of the verb chased, and it's also the subject of the verb phrase ate cheese. But I can do that again, right? I can now say "the mouse, the cat, the dog bit, chased, ate cheese." And now for most English speakers, this is going to start sounding kind of it suddenly becomes a little hard to keep up with, right? This starts to sound ungrammatical, or you start not necessarily knowing exactly what it means. You start being unsure exactly who did what to whom. And if you need a little bit more convincing, right, I can do this 4 or 5 or 6 more times. I can now say things like "the mouse, the cat, the dog, the child pet bit, chased, ate cheese," so on and so forth, right? So you can see that I'm applying the same grammatical rule. It's not obvious that I want to say that that grammatical rule shouldn't apply, right? I don't want to say that that third sentence is necessarily ungrammatical, but there's something about it that makes it hard to process. And we can see that that is a fact about processing, because we can make the sentence easier to process just by flipping some words around, just by changing what those words look like. So if I say something like "the guy everyone I know likes is nice," that now sounds a lot better, right? So if we think about the structure of the sentence, it's exactly the same. We have the main sentence, "the guy is nice," that's the matrix sentence, or the main clause. Inside of that, I have "everyone likes," right? So that's a reduced relative clause that modifies guy. So the guy is the object of the verb like, and the guy is the subject of the verb phrase "is nice." And then again, I play the same trick. I now put "I know," and I attach that onto "everyone." And again, the sentence sounds pretty good, right? So exactly why there's a difference here is something that people debate a bit, but the general consensus, I think, is that in the second sentence, somehow this is less difficult for our memory system, the memory system that has to encode the different noun phrases and the different verbs of that sentence and the structure of that sentence in a way that doesn't hold for the mouse, the cat, the dog, bit, chased, ate cheese, right? So there's something that is easier for the memory system in the second sentence that is not in the first sentence. Now, that already demonstrates something interesting, right? It demonstrates that how memory works tells you something about what sentences are hard to understand and what sentences are easy to understand. And that's the kind of thing that psycholinguists become interested in, right? We want to give some explanation for why that is, and then that means we have to say something about how language looks and how memory works. And that's not something that a typical syntactician would have to worry about in their usual day-to-day life anyway. Now, I want to get back to this idea about derivations, right? I want to get back to this idea that there are different stages of different intermediate representations of a sentence that are lined up or that have some dependencies between them, and that there's some kind of validity to that in terms of our psychological representation of a sentence. So in the beginning stages of kind of the modern era of psycholinguistics, people were very excited about this. People were very excited by something called the derivational theory of complexity. The derivational theory of complexity, I think, is worth talking about, especially with undergraduate students, because it's kind of the obvious first theory of psycholinguistics, I think, right? If you have these people telling you that sentences and words and morphemes are produced or comprehended in stages, right? Then an obvious first guess is that the way that we understand those sentences, words, and morphemes is by reversing the process, right? Whatever processes have been applied to a sentence, we then need to reverse those processes in order to get to the starting sentence, right? So just to give you an example, there was a lot of research that was looking at this this cube of complexity that I'll show you in a minute, right? And the basic idea is that as sentences become more complex, they become harder to understand. So what do I mean by the cube of complexity? So let's take a sentence like this: Mary hit Mark. This sometimes if you read very early generative syntax, this is sometimes called a kernel sentence. You can basically think of this as kind of the most unmarked sentence, right? A simple, transitive, declarative, affirmative clause. And we can think that there are ways to make this a little bit more complex, right? I can make it a negation, a negated sentence. Mary did not hit Mark. I can passivize this. I can say something like Mark was hit by Mary, or I can turn this into a yes-no question. Did Mary hit Mark? In early days of generative transformational grammar, these were actually transformations. So the idea was you start off with a sentence like Mary hit Mark, and then there's a transformation that introduces a negation into it. Or there's a transformation that passivizes the clause or turns it into a yes-no question. If you've taken syntax, you probably have learned slightly different theory, and that is the case. So these days, we don't usually think of these things as being transformationally related in this way, right? We don't necessarily think that a passive sentence is built out of an active sentence in that same way. But at this point in the 50s, 60s, and 70s, this was one way that people had talked about syntax, right? And of course, if we have the ability to negate a sentence, to passivize, or to question a sentence, then I can also passivize and negate, or I can passivize and question, or I can passivize and negate, right? So question and negate. So I can say something like, Mark was not hit by Mary. Sorry, I had a typo there. I can say something like, didn't Mary hit Mark? And I can say things like, was Mark hit by Mary, right? So again, what you'll notice here is that I'm now applying two of those transformations to that kernel sentence and producing sentences that are more complex. And of course, the coup de grace, I can then say something like, wasn't Mark hit by Mary, which is both passivized, questioned, and negated. And so if you draw the different relationships between these different sentence structures, you get this kind of cube shape, depending on how good you can draw shapes in keynotes, how good you are with the line tool. And there was a number of papers that came out in the 60s that demonstrated that basically sentences that are closer to each other on this cube of complexity are more likely to be confused, that sentences that have more of these transformations applied tend to be harder to remember, it takes people longer to understand. And there was a lot of apparent evidence that there was some truth to this, right? So there was some evidence that kernel sentences were the easiest and the fastest to remember. These kind of PQN sentences, passivized question negated sentences, were the hardest to understand. And if sentences sentences that involve negation were confusable with other sentences that had negation, right? So there's this idea that this was all evidence that these different stages of a derivation had some relevance for how we process those sentences. And that was a really exciting time, right? That really suggested that that barrier between competence and performance was transparent, right? We might be able to see through it and be able to make sense of what the grammar looks like based off of performance data, and we could think about predictions of how performance should behave based off of competence. Now, although this was a really exciting time, and although there was a lot of excitement about ideas like these cubes of complexity, it was also observed that there were some problems with the derivational theory of complexity. For one thing, it didn't quite explain all of the data. So I just gave you an example of this, right? So the difference between the mouse, the cat, the dog that chased ate cheese, which is hard to understand, and the guy everyone I know likes is nice, which is easier to understand, can't be attributed to a difference in the syntactic structure. If you look at these sentences, the relevant parts of the syntactic structure are basically the same. And if we think about these as derivational as sentences with derivations applied, it's not obvious that there's a different kind of derivation that's been applied in one but not in the other. If that's not clear, we can talk through the logic about that a little bit more in class. But by and large, these pairs of sentences only seem to differ in terms of what words are in the different noun phrases, and that seems to be controlling what is difficult and what isn't in these sentences. Secondly, not all transformations necessarily make language processing harder. There are some contexts in which a passive is more expected, and therefore a passive is easier to understand than an active. And there are other contexts where we think that sentences that look like they have had some transformations applied are actually easier to understand. And in fact, there's a couple of transformations or a couple of movements, to use the kind of more modern term, that actually do seem to make sentences easier to understand. And in fact, some might even argue that the existence of these constructions is to facilitate processing in a sense. So one example of this is something called heavy noun phrase shift. So here's a sentence. Ollie gave the toy mouse to Sniffle. Ollie and Sniffle being my two cats. And that's a grammatical sentence of English. But if I make that direct object a little bit more complex, and I actually give it specifically a more complex intonational contour with more stressed syllables, Ollie gave the toy mouse that was all chewed up and dirty to Sniffle. That sounds kind of funny, right? That actually sounds a little degraded, I think, to some people. There's something about the way that the syntax and the prosody of the sentence map onto each other that doesn't quite gel. And you can ask, you can ask your syntactician friends or your phonologist friends about why that might be. Now contrast that with a sentence in which we've moved that noun phrase out of the verb phrase. Ollie gave to Sniffle the toy mouse that was all chewed up and dirty. That sounds a lot better, right? So according to the derivational theory of complexity, that should not be better. That should be harder, right? So that was kind of one of the first cracks in this derivational theory of complexity, right? So that kind of suggested that just applying some transformation to a sentence as predicted by grammatical theory does not necessarily mean that the sentence should be harder to process in the same way. From this point, there started to become some other cracks, right? So one of those other cracks was that the theory of syntax started becoming more sophisticated, and we started developing theories that did not necessarily say that certain sentences, for instance, a negative sentence and an affirmative sentence, had the same kind of initial starting point and therefore were derivationally related. So that was one of the things that started becoming a little bit more difficult to contend with for advocates of the DTC, the derivational theory of complexity. But it was also becoming clear that that meant we couldn't, it also became clear that we shouldn't just get rid of this relationship between the grammar and the parser, or between our competence theory and our performance theory. There was a number of other interesting findings that suggested that sentence structure is not irrelevant, that the kinds of things that we describe in syntactic, semantic, and phonological theory were not just a completely different kind of mental object than what we study in sentence processing. So there's a couple of examples here, but one of my favorite examples is from Levelt in 1970, in which he had people do a number of different tasks. One of those tasks was basically judge how similar two words were in a sentence, or how related two words were in a sentence. Another thing that he did was ask people to listen to a sentence and then ask them what word came before or after some word in the sentence. And then what he plotted here was basically the conditional probability, or basically the essentially kind of like people's accuracy, let's say, on giving the right answer on that kind of cued recall task, or the kind of relatedness of those two words in the sentence. And then he plotted those relations. And what you might notice here is this looks a heck of a lot like a syntax tree, and that was kind of the point of his argument. The point of his argument was that syntactic representations that we describe in our syntactic theory are the kinds of representations that we store a sentence as in memory, right? So in other words, we don't store sentences as something different than the kind of tree structure, for instance, that we build in a syntactic theory. There were some other kind of interesting pieces of evidence that suggested that this is true. So this is by a study by Fodor and Bever, in which they compared sentences like, in her hope of marrying, Anna was impractical, versus Harry's hope of marrying Anna was impractical. Now, in the first sentence, Anna is the subject of the predicate was impractical, and in her hope of marrying is a modifier, right? Or that's a prepositional phrase that's attached to the sentence. Now, importantly, that means that Anna is not the object of the verb marrying, right? In other words, in this sentence, we're describing Anna's hope of marrying somebody else, right? Marrying, somebody. But if we compare that to a sentence like Harry's hope of marrying Anna was impractical, in that sentence, Anna is in fact the object of the verb marrying, and the subject of the predicate was impractical is Harry's hope of marrying Anna. Now, what I've marked for you here in this blue and this red dot, the blue dot corresponds to when, as people were hearing a sentence presented auditorily, when they heard a beep. And the red dot is where people claimed that they heard the beep. And what happens here is that if you played that beep kind of in the middle of a constituent, people would move it to be in between these major constituents. So in her hope of marrying Anna was impractical, they reported that they heard the beep in between the word marrying and Anna, but in the second sentence they reported that they heard it in between Anna and was, right? So that kind of suggests that what we're perceiving when we perceive a sentence lines up with big syntactic structure, right? Big phrases in the syntactic structure. So that, again, suggests that the kind of representations that we describe in a syntactic theory or a semantic theory or morphological theory is not nothing, right? It is still a model of something in our heads that we are building, representing, processing, and understanding when we understand a sentence. So I think one of the big turns, or one of the ways that we developed as a field in kind of modern psycholinguistics is the discovery of incrementality. So I'm going to tell the story a little bit backwards, but basically the discovery of incrementality means the discovery that people don't process a sentence as one whole unit, right? Everything I've talked about before, I was describing the sentence, right? And I was saying something about the derivational history of the sentence. I was saying something about the relationship between the sentence and other sentences, or, what part, how a sentence is stored or represented in memory. But we learned, also in the 70s, that people don't wait until they've encountered the entirety of a sentence to process it. One of the ways that we usually explain this, especially in kind of intro to psycholinguistics classes, is this experiment that again came much later in time by Altman and Comide. So in this experiment, Altman and Comide measured looking position as people listen to sentences like "the boy will move the cake" or "the boy will eat the cake." So this is an experimental paradigm that's called the visual world paradigm. And the idea here is that people will listen to sentences and then they'll look at a picture, and basically whatever part of the sentence whatever part of the picture that's most relevant to the sentence at any point in time is where their eyes are naturally going to be drawn to. What else are they going to do, right? They're sitting in front of a computer in this case, or in front of, a screen or something. They've got nothing else to do. They're listening to sentences and they have a picture in front of them. What else are they going to look at, right? They're going to look at the part of the sentence, part of the picture that has most to do, that has most in relationship, has the closest relationship to the part of the sentence that they're hearing word by word. And in this picture, you'll notice that they have a picture of a boy, they have a ball, they have a cake, they have a train, and they have a truck, a truck or something, like some kind of vehicle. And when a person hears "the boy will move the cake," those person's eyes might alight upon the ball or the cake or the train or the truck. But when they hear something like "the boy will eat the cake," their eyes beeline right to the cake, because the cake is the only thing in this picture that's edible, right? So that seems to suggest that you don't have to wait until you hear the word cake to notice that this sentence is probably going to have something to do with the cake. Hearing the verb eat is enough information at the verb eat to know that the sentence is going to probably end with the word cake. So what I'm showing you on this graph here, the y-axis is the probability that people will look at the picture of the cake. And if you look at this, the line with the circles on it, the black circles, is what happened, where the eyes are looking when the person hears "will eat the cake." And around 400 milliseconds, we see that's the offset of the verbs. That's the end of the verb eat, right? That's the "t" sound, basically. And you see that people are pretty much looking at the cake by that point, right? Before they even hear the word cake. And they're doing this more so than when they hear the word move. So that shows you that it's not just that the cake is the most interesting thing on the picture, right? When they hear the word move, yeah, they look at the cake about 20% of the time, but they're looking at the other stuff too. But when they hear the word eat, they're looking at the cake more often. So what does this demonstrate? Again, this demonstrates that people are doing things, right? They're building parts of the meaning of the sentence. They're building parts of the sentence's representation as they accumulate information. As words come in, they update, add to, and change their interpretation of the sentence, right? So this idea that we should be able just to relate, say, a negated, passivized question to the declarative sentence is maybe not quite the right path, because different words are coming online at different points in those sentences. And when a person processes that sentence word by word, at different points, they're going to be doing different things, right? So that's part of, I think, the problem with that kind of approach that people were taking in the 60s and 70s. Actually, what really tipped people off to this finding is the phenomenon of garden path sentences. So some of you have taken psycholinguistics too, and you've talked about garden path sentences to death in that class. Some of you maybe have encountered this in passing before, and maybe some of you haven't heard of garden paths at all. But a garden path sentence is basically a sentence in which the first part of the sentence seems like it's going for one analysis, but then something happens at the end that tells you you had the wrong analysis, and you kind of have to start over. So the example that linguists love is a sentence that, again, some of you are already groaning because you know what's coming up, a sentence that starts with the horse, right? So at this point in the sentence, we probably are committed to the idea that the horse is a noun phrase, and that's probably the subject of some clause. And so far, so good. And then if we continue in the sentence, we might encounter the word raced. So now we have the horse raced. Now at this point, we could suppose that the horse is the subject, it's a noun phrase, and that the raced is the predicate, right? That's the verb inside of the verb phrase. That's a pretty kind of straightforward and obvious analysis. Alternatively, we could go for something a little bit more tortured, right? We could suppose that this is a part of a reduced relative clause and that there's probably another verb coming up later. So a reduced relative clause are expressions like the horse chosen by the jockey, right, which is a shortened version of something like the horse that was chosen by the jockey. So in this sentence, you'll notice there's no complementizer that in order to mark that that's a relative clause, and we don't use the passive auxiliary was. So this is an unusual thing that we get to do in English. A lot of other languages don't do something like this, but this is something that we're able to do in English, right? So in other words, when we hear the horse raced, we could suppose that raced is not the main verb, but rather it's part of the super complicated modifier. And if we make that choice, then maybe there's another verb that might come up later, right? Now, the observation is that second hypothesis does not really seem to be entertained. Just like we talked with child language acquisition, right? We have to think, what's the hypothesis space and what are people's prior biases about which interpretation they're going to prefer? And apparently, people don't really seem to notice that more complex interpretation right away. So we opt for the first interpretation, the horse raced, where raced is the main verb. Then we move on with our lives. We get to the prepositional phrase past the barn. The horse raced past the barn. That sounds like a totally suitable thing to raced past, so far so good. And then we get to the verb fell. And if we think about this, there's really no way to incorporate the verb fell into the structure and still have this be a grammatical sentence. The horse raced past the barn fell, right? Fell can't be the main verb because raced is the main verb. We already have a main verb. In fact, we've already kind of completed the sentence, but now we have this whole new predicate without any subject. What are we supposed to do? Well, what we're supposed to do is we're supposed to start over, right? Or we're supposed to abandon this line of processing the sentence and go back to that much more complicated sentence, right? That much more complicated sentence structure. So the way to understand the sentence is something like the horse raced past the barn fell, where raced past the barn is a reduced relative clause, right? That tells you that the horse was raced past the barn by somebody and that the horse fell. So fell is the main predicate. Raced past the barn is all part of that big noun phrase. That's the idea, right? And if you want to convince yourself of this, consider the sentence, the horse ridden past the barn fell. So the reason why we are garden pathed in this sentence, the reason why we are misled to the wrong interpretation is because that verb form raced is ambiguous between a main verb form, right, or a participle. It could be part of this kind of modifier. So some verbs make a distinction. So the verb ride, at least in my English, is rode in the past tense and then is ridden in the participle. So for me, if I want to say the main verb use, I have to say the horse rode into the sunset or whatever, or the horse rode past the barn. But if I want to use the reduced relative clause, then I have to say the horse ridden past the barn fell, right? So that disambiguates, and that should mitigate this problem a bit. So the point here, what I'm trying to stress here, right, is that we've learned something about sentence processing, and the problem with the horse raced past the barn fell is not the verb raced, it's the verb fell. When we get to that verb fell, that's when we realize that there was a mistake, and that is what causes things to become difficult, because at that point, we have to reanalyze the sentence. Right. So the problem arises because of the ambiguity of the word raced. But if you hear the horse raced, Nothing funny is happening at that point because we have a hypothesis that raced is the main verb, and the data so far is totally compatible with that hypothesis. It's not until we get to the verb fell where we go awry, right? And when we get to that verb fell, that tells us we have to do something different with our analysis. We have to reanalyze the sentence. Again, in Psycholinguistics 2, we spent 5 weeks talking about reanalysis, but the basic idea, again, is that something challenged your initial interpretation of the sentence, which forced you to redo it. And that redoing of the analysis, in some sense, is why the horse race past the barn fell is hard. So incrementality is the name of the game here, right? The fact that different things happen at different words is super, super, super important. And so what happens at words, right? Well, words do lots of things, and one of the things that words do is they relate to other words at long distances. So another interesting thing in my mind, or another interesting example of kind of competence performance divergence, or where we can say something interesting from the processing theory about what sentences sound good and bad, are examples of agreement. So I want you to consider the sentence, "The key are old." This, to most speakers of English, is obviously bad, right? If you hear "the key are old," that is no good. And it's no good because are is a plural verb and key is a singular noun, right? So that sounds pretty bizarre. Oops, I went the wrong way. But if you hear something like, "the key to the cabinet are old," so I made the subject noun phrase a little bit longer. I added a prepositional phrase. I mislabeled that, sorry. But obviously, "the key to the cabinet are old" is still obviously ungrammatical, right? My knowledge of language tells me that's ungrammatical. And as I process that sentence, I immediately notice that that's not right. But now consider this sentence, "The key to the cabinets are old." Now, maybe I've primed you to notice that this is ungrammatical, but for a lot of people, this does not immediately strike them as ungrammatical. So the subject should be, so the subject is the word noun key, which is singular, so therefore the verb should be singular, but people seem to be tempted or misled in some sense by that noun cabinets. Right, so the verb, if you counter the plural verb are and you have that plural noun cabinets, that somehow seems to repair or heal the violation of having the ungrammatical subject-verb dependency. Now, this isn't a garden path, though, right? So this isn't a case in which you're misled to one interpretation and then something else tells you you had the wrong interpretation, right? If anything, it's kind of the other way around, right? What we're seeing is that people have all of the information they should need before you get to the verb, right? When you hear "the key to the cabinets," well, you know key is the subject of that sentence, so the verb should be is. But nonetheless, when you get to that are, if you have that plural noun cabinets, it still seems to sound not so bad. So this is a phenomenon that's called agreement attraction, and we don't really think of it as a garden path. We think of it as a problem with memory. We think of this as maybe I shouldn't say a problem, but we think of this as diagnosing an interesting feature of memory. So the idea here is that when you have something like "the key to the cabinet are old," or "the key to the cabinet is old," is the grammatical verb here, and it's grammatical because is needs to find the subject of that sentence, and it needs to find a singular subject, right? And in the sentence, "the key to the cabinet is old," there is a singular subject. It's key, right? So that is grammatical, and then "the key to the cabinet are old" is ungrammatical because are needs to find a plural subject, and there are no plurals in the sentence, right? But when you hear something like "the key to the cabinets are old," in this sentence, are wants to find a plural subject. Well, there are no plural subjects, but there is a plural noun. There is this noun cabinets. So the idea is that you kind of grab the wrong noun. You misretrieve the noun cabinets instead of the noun key. Now, there's a lot more to say about this, and again, to learn more about this, talk to your psycholinguistics friends, come to psycholinguistics class, or come to our sentence lab or S-lab meetings to learn more about this. This is something that we still very actively study a lot. When and how and whether people notice agreement errors as a window into how memory works is a big topic in psycholinguistics and has been for quite a while. But this again demonstrates, right, that things that happen at different words are to blame for when processing becomes easy or when processing becomes more difficult, because of the requirements that they place on memory, and not necessarily because of anything interesting about the competence, right? Nothing interesting about the grammatical structure per se, right? So nothing is interestingly different about the grammatical structure between these two sentences. They're both ungrammatical sentences if the verb is are, and they are grammatical sentences if the verb is, but that detection of ungrammaticality is weakened in that second sentence if you have that plural noun cabinets. Incidentally, memory is also probably one of the reasons why that second sentence is, in this pair of sentences, the guy everyone I know likes is nice, is easier than the mouse, the cat, the dog bit, chased, ate cheese. So one interpretation of this phenomena is that in the first sentence, the mouse, the cat, and the dog are very confusable in memory. They're both noun phrases that start with the. They're both short monosyllabic nouns that describe an animal, in fact, right? So they have a lot of syntactic, semantic, and even phonological features in common. But in the guy everyone I know, well, I is a short, unstressed pronoun. Everyone is a quantifier, and the guy is a definite noun phrase that uses a lexical, that has a noun inside of it, guy, right? So the idea is that in these reduced relative clauses, every time we get to the verb know, I need to retrieve everyone, because everyone is the object of the verb know. When you get to the verb likes, you need to retrieve the noun guy, because guy is the object of the verb likes, and it's easier to distinguish those noun phrases in memory because they don't look so similar to each other. But in the first sentence, they look kind of similar, and therefore they're more confusable, and therefore it's harder to resolve those dependencies. So what is the point here? The point here, right, is again, how we understand processing difficulty isn't we look at the tree structure and we say, this tree structure looks hard, this tree structure looks easy. Instead, we pin the blame on psychological processes that are happening at different stages of processing the sentence. And that's the key here. That's what psycholinguists get excited about, right? In a way that is kind of domain specific, right? In a way that is not necessarily part of the research program that people study in syntax, let's say, or semantics or phonology. So with that in mind, let's now turn to the real topic of this paper by Phillips and Wagers, which is the phenomena of long-distance dependency, right? So long-distance dependencies, by this we mean movement dependencies, or A-bar dependencies, as we call them in syntax. Psycholinguists also sometimes call these filler gap dependencies. These go by a number of different names for various reasons, but basically what I'm referring to is whatever is going on when you hear a sentence like, who did Jane see, right? In this sentence, who does two things in the sentence. It tells you that this is a WH question by sitting at the left edge of the sentence, and it also has to be understood as the object of the verb see. So it plays two roles. It marks the scope of the WH the WH quantifier. It tells you that this whole thing is a WH question, and it also is the object of the verb see. Now, if you've studied syntax, and I hope someone corrects me if this is not quite how we teach it here, but you've probably learned something like the following theory in your syntax class. That theory is something like you have a D structure in which who is the object of the verb see. It's the complement of that verb phrase. And then you move some stuff around, you stick in some traces, and who is now in spec CP, and it has a trace in that lower position. So this is what we mean by a transformational theory, right? You start with one representation and you do some stuff to it, and the output of that is a different kind of representation. And again, the natural way to think about this, if you are, first theorizing about sentence processing, is when a person hears, "Who did Jane see?" what they have to do is they have to undo those movements, right? You have to kind of reverse the process. But there's another way to think about this, right? And I think this is what Phillips and Wagers are really trying to suggest in their paper, right? Or this is one way, I think, of reconciling what they are talking about in their paper with how we think about formal grammatical theory in general. Instead of thinking about this as one tree structure that gets turned into a different tree structure, we think of the representation of the sentence as two structures that are connected, right? The syntactic theory tells us that there are some features that have to be shared in common, right? That tells us what the relationships between the thing on the left and the thing on the right has to be. But we can basically think that whatever a person is building when they're processing a sentence, word by word, is they're assembling pieces of this pair of trees, word by word, right? If you've taken more advanced syntax classes, if you've learned about the minimalist program, then you've learned that maybe we don't have two structures, maybe we have lots and lots of structures, right? Maybe we're iteratively applying some operation called merge, which builds some tree structure kind of piece by piece. Same argument, right? We can think of the sentence structure not as a tree or two trees, but as a series of trees. Grammatical theory tells you what the connections between those trees are. That's fine. And then in psycholinguistics, what we're asking is what bits of those trees are being built word by word. And you can keep playing this game. And in the paper by Phillips and Wagers, they go through some other theories of syntax, which you may or may not have even heard of. They mention HPSG. They also mention LFG in passing. So LFG is a theory that I was taught in my undergraduate school, in which we learned that there's a tree structure that we call the C structure, and there's another thing that we call F structure. And F structure basically encodes information like what is the subject and what is the object, right? So what this basically tells you is my C structure is kind of the constituency, basically what, S structure looks like in government and binding, or what you learn in syntax 1. And F structure basically tells you that who is both the question word, and it's also the focus of the sentence, and it's also the object, right? So it's what I'm trying to say here, right, is different theories of syntax all have this idea that there's lots of different kinds of information that are represented in the analysis of the sentence. And what we're trying to capture by talking about long-distance dependencies is that word who at the beginning of the sentence does two things. It is both the object of the verb and it marks the question, right? That's what we're trying to say. But as we just said on the last few slides, sentence processing is not something where you hear a whole sentence and then you build the structure, right? People are building that sentence structure incrementally. Every time you hear a new word, you update, add to, change, manipulate that structure, right? So if we go back to kind of the government and binding style model of the grammar, where you have a D structure and S structure, just for the sake of simplicity, when you hear the word who, well, at that point, what structure have you built? Well, I mean, we could spell it a couple of different hypotheses. One, well, for sure, if you hear the word who, you know that on the surface, you have the word who at the beginning of the sentence, obviously. But maybe that also then means you can guess, well, according to the rules of my grammar, if I have a double H word at the beginning of the sentence, then there's probably a trace somewhere downstairs, right? There's probably a position that I moved from. And maybe you might even guess, well, if there's a trace in that sentence, it's probably in a verb phrase, right? And if it's in the verb phrase on the surface, then that's where it moved from in D structure. And then if you get to the word did, then you can say, okay, well, now I know I have that C bar part, right? I know that if it's the word did, then that's a past tense verb. And that means that I moved the past tense from a T node, right? And then if I have moved from the T node, then that means on my D structure, I had a past tense marker in my T. When you get to Jane, you can put Jane in. And then when you get to the verb see, then you can put the verb see in. So again, there's a lot of trees today. What am I trying to say? What I'm trying to say here, right, is that there's no necessity to assume that the part of the structure that a word corresponds to is the only thing that gets built every time you incrementally add a word to your parse, right? When you hear the word who, you know that there's the word who in the sentence, but you know other stuff too. You also know, according to the rules of grammar, that that word who probably has moved from some position, right? Or it has a gap that it's associated with, right? It has to be the object of a verb or the object of a preposition or the subject of a verb. It has to have some other role in the sentence. And you might be able to plan for that, or you might be able to build that bit of structure ahead of time. There's no commitment to this idea that as you process a word, you are only kind of activating or adding that bit of that word to the structure, right? There's no reason to suspect that sentence processing has to be linked that closely to the representation. Now, why am I harping on this, right? I'm harping on this because this makes it really hard to think about how the parser and the grammar relate to each other. It makes it very difficult to be precise in terms of our model of how the grammatical representation that we study in our syntax class gets mapped onto the psychological processes that we study in sentence processing. Now, just to be clear here, this is something I'm very excited about personally. This is something I've spent time thinking about. I had a paper come out last year, specifically trying to ask this question about how much syntactic and semantic information do people build when. I mean, this is something that you can study, right? And we are still learning how to link these together. The derivational theory of complexity was a really clear, good hypothesis. It just wasn't quite right. And it turns out the world is more complicated than that, right? But we do know some things about filler gap dependencies. So this doesn't mean it's like an impossible problem to solve. We've learned some things that are pretty surprising, I think. So in the Phillips and Wagers paper, they mentioned this paper by Laurie Stowe. For the psycholinguists in the audience, this was a self-paced reading task. And the self-paced reading task was looking at sentences like this. My brother wanted to know who Ruth would bring us home to at Christmas. And in this experiment, Laurie Stowe was super interested in knowing exactly what happens when you hear the word us. Now, here's the logic, right? The logic is, let's think about what that sentence looks like before you get to the word us. Before you get to the word us, the sentence looks like this. My brother wanted to know who Ruth would bring. At this point, we've presumably built some structure that has the double H word who in spec CP, if we're assuming kind of a traditional, Chomskyan syntactic analysis, or whatever your favorite theory of syntax is, whatever the equivalent of that is. And we also have the predicate bring. Now, at this point, we could hypothesize that who is the object of the verb bring. And if in terms of our representational theory of grammar, if that means there's a trace there, so be it. If it means however you want to cash that out in your favorite theory of syntax, that's how it gets cashed out, right? That who is the object of the verb bring. And then we get to the word us, and we find that that analysis is wrong. So this is a very similar logic to the garden path idea, right? The idea is that the sentence could be interpreted one way, and if people get confused, or if reading time slowed down, or if you're doing a brain recording experiment and your brain squiggle goes one way, not the other way, that might tell you that people are struggling or are shocked or surprised or having some kind of processing difficulty because their favorite hypothesis was wrong, right? Their hypothesis about what the structure of the sentence looks like happened to be wrong. And in fact, that's what Laurie Stowe found. Laurie Stowe found that when people read the sentence, my brother wanted to know who Ruth would bring us home to at Christmas, people slow down at that noun phrase us compared to the control. The control condition, if you're curious, is something like, my brother wanted to know if Ruth would bring us home to somebody at Christmas. So in the sentence, who is actually the object of the preposition to. However, before you even hear the word to, before you hear the word us, before you have finished processing the noun phrase us, you at some point had considered the hypothesis that the tree structure looks like the thing on the left that I've X'd out, right? That the tree structure looked like something in which who is the object of the verb bring. And then when you get to the word us, that's the cue that you made the wrong choice. So in this case, the word us is a lot like fell in the horse race past the barn fell. That's not nearly as extreme. When you tell your mom about the horse race past the barn fell, she'll look at you funny, but people don't really notice this kind of garden path that I'm presenting here on the screen. But this is a kind of garden path, you might say. So what does this tell us? Again, what this tells us is something interesting about parsing. This tells us something about the psycholinguistics of this phenomena. What this tells us is some time before reading us, we have committed to an interpretation. We've built the tree structure in which who is the object of bring. And then once we've finished processing the word us, we realize we made a mistake, right? And then we have to resolve that mistake somehow. This is a principle in psycholinguistic theory that's called the active filler strategy. And there's a couple different ways to say this. The original formulation of this, I think, is well, I won't say I think the original formulation of this is a little confusing, but one way to understand this is something like, whenever possible, and you have the option of positing a gap or a trace or whatever you want to call it, try that first, right? Anytime you find an ambiguity where a double H word could have been moved from that position, suppose that it's been moved and then see if you're right, right? That's kind of one way of formulating this. Now, I'm talking about this because there was some work in the 80s and then in the mid 90s that was trying to use psycholinguistic evidence to argue against the idea of traces, right? So again, correct me if I'm wrong, but in syntactic theory, you're probably taught that whenever you move something, you have to leave behind a silent element, right? A null element that in syntax we usually call a trace. You might have learned about quote-unquote lower copies. It's the same idea, right? Anytime you move something, you're actually leaving something in that initial position that has some life in the syntax, right? And you can posit rules over traces or lower copies. You can talk about things like reconstruction effects or and so on and so forth. But there was an attempt to argue against that theory by using psycholinguistic evidence. And the kind of experiment was a very similar experiment to what we just discussed. So in this experiment, they were looking at sentences like, "This is the city that the author wrote unceasingly and with great dedication about." And the logic of this experiment was, we have a gap, right? And it's really, 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 really far after the verb wrote, right? It's after the preposition about. And we also have all of these adverbs here, unceasingly with great dedication, that would basically separate out the verb from the putative direct object position, right? You can say something like, the author wrote unceasingly with great dedication a book about blah, 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 for instance, right? But the idea was that in this experiment, they wanted to see whether people were confused or surprised when they get to that verb wrote, because wrote is a kind of a weird verb to use if the city is the object, right? In other words, we don't normally write cities, right? So their argument was, we can explain the processing of these kinds of structures not by having a movement dependency, not by having traces, but just by, they posited, we just can directly link up that noun and that verb, right? And so what they found is exactly what I just suggested. What they found was that people did in fact slow down. For the psycholinguists, they did an eye tracking while reading study, and they found, I think in late measures, if I remember correctly, that our reading times were slower at the verb wrote compared to something like, "This is the book that the author wrote unceasingly and with great dedication about." So the argument was, before any of this gap nonsense, right, before you have any reason to suspect that you have a gap, you have noticed that city is a bad theme, it's a bad object for the verb wrote. And that's enough information to notice that that sentence is not the right analysis of the sentence, right? That's enough to be the reanalysis cue. That's enough to tell you that you need to revise your hypothesis about the sentence. Now, the point that Phillips and Wagers make, and again, I agree with this point, is that can't be the right interpretation. That's assuming that what happens in the parsing has this like one-to-one correlation with what's happening in the representation. Just because something happens at the verb does not mean that the relevant part of the representation is the verb. In other words, one way to understand this is, as people are reading, "This is the city that the author," sometime before people have completed processing the verb wrote, sometime before they have completely finished understanding the word wrote, they had entertained the structure. They had entertained a structure in which city corresponds to the object of the verb. They may have even made that prediction, or they may have even made that commitment before they even encountered the verb wrote, right? Maybe people have considered the hypothesis that city is the object of the verb that comes after author before they even heard or saw or read the word wrote, right? That's also a possibility. And then once you've finished processing the word wrote, that is the cue that results in a bizarre semantics, right? You don't write cities, again, you write books and poems and novels or whatever, you don't write cities. But that bizarre semantics is the cue that the structure you had already built was wrong. Same logic as the Stowe study that I showed you a couple slides ago, right? All that we can really infer is that by the time people have their processing difficulty, they had built some interpretation of the sentence. Now, this is part of the reason why psycholinguistics, I think, and syntax and semantics and morphology are kind of different fields, because now we've learned something about processing filler gap dependencies that's pretty complicated, actually, right? Again, how this works is still something people are studying. I just mentioned I wrote a paper on this very recently. Some of my colleagues are working on this topic too. When we look at other languages, other things are relevant. There's a lot to say here, right? And what we're still learning is exactly how the processing algorithm, the parsing algorithm, lines up with different parts of that grammatical representation, and what parts of the grammatical structure are built at what point in the sentence. Again, psycholinguistics is really a theory about how things happen in time or over time. Whereas in syntax, we're really describing the structure of a sentence kind of disjoint from time in a sense, right? We're not really talking about things that happen millisecond by millisecond in the same way as we are when we study psycholinguistics. So I want to talk, so this means it's hard to align them, but notice that like it's still useful, right? So I admit I did my song and dance when we were talking about language acquisition about how even with a highly rich internal native universal grammar, explaining child language acquisition is still very, very tough, right? Because even if we suppose that children have access to all of that knowledge, they still have to use that knowledge, and that's the part that's hard, right? The same point applies here, right? The same point applies here, that we can start gaining some insight in how grammar lines up with psycholinguistic mechanisms by thinking through this problem very carefully and very seriously, and asking ourselves questions like, how much structure is built at this point in the sentence? But the answer is not going to be easy, right? This is still going to take some time and some work. And that's what we're going to turn to next time. Next time, we're going to talk about island phenomena. So the moral of the story up to this point is that the linking hypothesis, right, the way that we correlate or connect psycholinguistic mechanisms and grammatical knowledge, our competence, is tough, right? But it's worth trying out. It's worth trying to do this carefully. And it's the tools that we get from theoretical linguistics are very useful for having some kind of hypothesis space for how things might look and how things might work. Next time, we're going to talk about islands. Islands, we've already mentioned this once in passing. Islands are kind of a funny phenomenon, right? It's a construction that you cannot move out of, to put it in syntax terms. To put it in filler gap dependency terms, an island is a structure that a filler gap dependency cannot cross. And just to give you a little amuse-bouche here, I mentioned that in this Traxler and Pickering 1996 study, they discovered that when a person reads, "This is the city that the author wrote unceasingly and with great dedication about," people get a little confused at that verb wrote. But when they hear, "This is the city that the author who wrote unceasingly with great dedication visited," there is no surprise at that word wrote. People don't get confused that the noun phrase the city is a bad object for the verb wrote. Now, why is that? The suggestion is that they are not considering the implausible meaning in which wrote is the verb that takes the city as its object, because you're not supposed to cross a filler gap dependency into a relative clause, right? It sounds kind of funny to say the city that the author who wrote unceasingly and with great dedication is called, War and Peace. That sounds kind of funny, right? I'll unpack that more next week. We're going to talk about islands, why linguists love islands, why we like to argue about islands, what we know about them from sentence processing and this active filler strategy stuff, what we know about them from child language acquisition. We're going to wonder, how could a child ever learn these things ever, even with universal grammar? And we're going to think a little bit more carefully about, right, what this really tells us about the nature of language. And we'll talk about that next week.